You need to start viewing coding as a tool for your own curiosity. Right now, that mindset is both easier and harder to hold on to than ever before. Because on the one hand, we live in a time where you can literally vibe code and spin up apps, games, tools, or whatever you're curious about with almost no obstacles. But on the other hand, it's ridiculously easy to get overwhelmed or lost in all of the computer science clutter. There's almost this endless stream of tutorials, frameworks, and influencers telling you which language to learn or what projects you need to build for your resume. And this is especially apparent if you go on social media and you see all the posts saying AI is taking over and CS is dead. All of this noise and all of this clutter really just goes to kill your curiosity. So if you want to actually get good at programming, like really grow and enjoy it, you have to protect that spark. You need to drown out all the pressure, the trends, the perfect language, all of that, and just zoom back into why you even started in the first place. And so that's why I call this the curiosity rule. You need to stay curious, really curious about whatever interests you, even if it doesn't feel perfect, and even if it feels random or not useful. For me, I got into computer science because I wanted to make my own games. But I still remember how fun it was to build and play test my own games, and it was even at the point where it was more fun than playing actual official studio games. And at this point, coding became less about the code and more about chasing something that I was actually excited to build and just using code as a tool for that. And so that's what made me learn Python really fast. It's because I was using it to create my own games. And think about it, you're way more likely to finish a project that you actually care about. So if you care about a project and you're actually curious about it, that means you'll finish faster and stay motivated longer than if you were just copying whatever some influencer told you to build. So in a weird way, coding your own interests actually makes you code more and get better faster. So chase your curiosities, because it's not just good advice, it's literally almost a shortcut. So this is a piece of advice that I feel like can really apply to anything, but it's especially apparent in the world of computer science and programming, and that's to build systems, not just goals. And I'm not trying to say don't set goals, because I think they're actually really important to have, but what I've noticed about goals is that people might initially be motivated to try and reach them, but as soon as they realize how difficult the goal actually is, their motivation starts trickling down, and eventually they either forget about the goal completely or just abandon it. And with goals, I feel like a lot of the time you either burn out trying to hit them or you miss them entirely and feel like a failure. So that's why I stopped focusing so hard on goals, and instead I started thinking in terms of systems. A system is just like a daily process. Like, let's say you have the goal of finishing a React course by the end of the week. For that same example, what your system should be is every weekday I want to spend 45 minutes coding and just write notes about what I learned. And that's it. No dramatic countdown, no deadline anxiety, just a small system that you can actually stick to. And I really like systems because they kind of protect you from that feeling where you think that you're not doing enough. Because on the other hand, if you have a really big goal, it's really easy to compare your progress with the final end result and then get demotivated. But with a system, and if we take the example I said earlier, all you have to do is just 45 minutes of coding and then write notes about it. And I think we all know steady progress is a lot better than no progress. And I'm not trying to say don't have dreams or long-term goals, because I think those are really important to have. But if you're serious about wanting to become a good coder or honestly get better at anything, don't just set goals, but build systems around them. Okay, this one kind of conflicts with the system ideology, but this is assuming that you already have that consistency in coding, and now you're looking to go all in on something. So Parkinsons Law states that work expands to fill the time available for its completion. And honestly, from my experience, that's pretty accurate. Take a 2-hour project, for example, and if it's due by the end of the day, I'll spend most of the day thinking about it and stressing over it, but not actually doing it. It'll linger in the back of my mind, time, but because I know it'll take a while, I'll hesitate to start. And that anxiety leads to procrastination, and before I know it, the day's almost over. And so suddenly, with only 2 hours left, the exact amount that the time actually needs, I'll finally feel the pressure to get it done and actually start it. And sure, even if I finish the project, I still wasted a huge chunk of the day just thinking and stressing about it, whereas I could have knocked it out early and had time to relax or work on some other things. So yeah, in my experience, Parkinson's Law is definitely real and can definitely be a problem. But here's the thing, if we understand it, we can use it to our advantage, especially as programmers. Because think of all the times you started a project only to forget about it a few weeks later. What if instead you created a timeline from the very start? And it doesn't have to be crazy, it can be something really simple, like just set a date for your minimum viable product, another for improving user experience, and another to clean or optimize your code. And here's where Parkinson's Law kicks in. Those dates have to be just tight enough so that your initial burst of motivation can carry you straight to the first deadline. So you don't give yourself time to get bored or overthink it or abandon the project. And if you've ever done a hackathon, you know what I mean. You can build something fast, focused, and functional in just a weekend, because for some reason, when our brain sense pressure, it allows us to do some of our best work. And so let's say you reach the first milestone, and like I said, you have your minimum viable product that works. Maybe it's not that good, but at least it works. At this point, even if you do decide to stop and you don't decide to further optimize it, at least you have a working prototype. But then let's also say that you don't decide to stop and you use Parkinson's Law really well and you stick to your next deadline. Then you'll start hitting your other milestones, like refactoring the bad code or polishing the experience or improving the design. And before you know it, you've turned what could have been an abandoned side project into something actually good. Okay, this is a bit more of a niche tip, but one that I think will really make you a good programmer. It's the concept of steal and twist. So for this tip, I'm assuming that you already have some project or some code that you've done in the past. And what I recommend is finding another code base that does something similar and then just compare the two. You should try and see, what is this code base doing that I'm not? How do they structure things? What helper functions do they have? How do they test and modularize their code? How do they name stuff? And this can work for any level. If you're just starting, take a simple project like a to-do list and then find one on GitHub that's better than yours, and don't just copy it, try and study it. And then from here is where you actually implement the steal and twist. Now when I say steal, I don't mean just copy and paste, but basically after you're done studying, I want you to refactor your code, taking into account any improvements you saw from the other code. And then, this is the key twist part, I want you to rebuild yours with your own twist on it. This way, we can really ensure that you're not just reading other people's code and memorizing it, but you're actually understanding it and remixing it with your own style and understanding. There's a trap in computer science that I feel like a lot of people have fallen into, especially nowadays, and that's the trap of becoming a theorist rather than a practitioner. And don't get me wrong, theory is really powerful. Understanding data structures, algorithms, runtime complexity, and especially if you want to get into research and things like that. But here's where most people go wrong. They confuse knowing these things with actually doing and actually coding. Like, I've met so many students who can explain these computer science topics and even pass all their classes with A's and have a 4.0. But if you ask them to build a simple project or even give them an easy LeetCode problem, they freeze. It's like all that knowledge they have just disappears the moment a code editor actually opens. And this is because theory without practice is like studying the rules of chess but never having played a game. And with coding, it's basically the same deal. But if you are a practitioner, this means you extend and actually apply the theory that you learn. You actually build the projects, you debug them, you figure it out, you build even better ones. And that's when the theory actually clicks. So clearly, you want to be a practitioner. You want to be somebody who knows all of the theory and can apply them in a meaningful and useful way. But that begs the question, how do we learn all of this knowledge and actually have a place to apply it? And that's why I use today's sponsor, Brilliant. Brilliant helps you get smarter every day with thousands of interactive lessons in math, science, programming, data analysis, and AI. Brilliant is a learning app designed to be uniquely effective. Each lesson is filled with hands-on problem solving that lets you play with concepts, which is a method proven to be 6 times more effective than watching lecture video. Brilliant's first principles approach helps you build understanding from the ground up. And with a perfect mix of engaging problems, competitive features, and daily encouragement, all keeps you motivated and on track. Plus, all content on Brilliant is crafted by an award-winning team of teachers, researchers, and professionals from Stanford, MIT, Caltech, Microsoft, Google, and more. And the Brilliant app makes it easy to learn anywhere, right on your phone, with fun, hands-on lessons that you can do whenever you have time. So whether you're diving into a new topic or doing a quick practice session, you can level up on the go in just minutes. And Brilliant's newly updated programming courses are a great way to build a foundation in coding and to get experience with real-world applications and to actually learn to think like a programmer. Brilliant allows you to build timeless problem-solving skills to thrive in the evolving world of programming. It also teaches you to learn to think like a programmer by breaking down complex problems into manageable chunks of code. Brilliant also allows you to develop an intuition for computer logic as you learn to design and debug real problems. You can also get familiar with Python and start building programs on day one. So to try everything Brilliant has to offer for free for a full 30 days, visit brilliant.org/lattice or scan the QR code on screen, or you can click the link in the description. You'll also get 20% off an annual premium subscription. So once again, huge thank you to Brilliant for sponsoring the video. It really means a lot. And if you made it this far, I just want to say thank you. I really appreciate every single one of you that watches the videos and comments. And I hope I was able to give you some good advice and help you in some sort of way. And that's all I got for today.